Hi guys. So today we're going to continue with Unit 4 and similar triangles. But today we're going to learn how you name triangles. Or how you classify triangles. So there's two ways we classify them. One by its angles and another by its sides. So the one you're most familiar with, or actually you should be familiar with both, maybe just not at the same time. So by angles, there's four different kinds. There's acute angles, which we just label acute, right? And the only requirement for an acute angle is that all the angles have to be less than 90 degrees, right? Then we have what we call obtuse triangle. And the requirement for that one is that it has at least one angle greater than 90. So one angle greater than 90. And for a right angle, right angle has to be exactly 90 degrees. And then this last one, we have all three angles that are congruent, right? So let's think about it. If we add up all the angles and they're supposed to equal to 180, right? So they're supposed to equal to 180. And we just said they all have to be exactly the same. So we do 180 by 3, which is telling me that each angle measures 60 degrees, right? And so that's what we call equiangular. And so the other method that we classify angles is we classify them according to their sides. And so here, for the first one, we have any triangle that has three congruent sides is what we call an equilateral triangle. Any side that has two congruent sides, we call an isosceles triangle. And one that has no congruent sides, so no congruent sides would mean that none of them are the same, then that is what we have a scalene triangle. So let's practice identifying these triangles. So here I'm given a cluster of triangles, right? And so we're going to go through each one of these individually. But before we do that, let's go over here to the diagram and label everything that we can, right? So this right here means that that's 90 degrees, right? And so if that's 90 and means this is 90 as well, okay? This little marking there means that if this is 8, that means this side is also 8. One key thing, if that's 60, remember, that means that all the other ones are also 60 and 60. Okay. Now, because we know that this is 90, this is supposed to be 90 as well. And so if I already know that that little angle there is 60, that means this angle here is 30 because they have to add up to 90. And so it takes us back to the fact that if we know that all three angles, when you add them up, should equal to 180, and that's 30 and that's 120, that means when you put them together, that's 150, which is telling me this is 30, right? Another way I could have known is the fact that because the sides are the same, the angles are going to be the same, right? So isosceles triangle there. One other thing, so if that's 60, 60, 60, that means this is an equilateral triangle, which means this side is also 8. And I believe that's all we need. All right, so now let's go through and answer these questions. So for the first one, it says triangle UQR. Okay, so triangle U, where is U? UQR. Okay, that's my attempt of highlighting. Let me see if we can do a better job. So purple. Okay, so UQR. Okay, so we're gonna try to color code this. So it's saying classify this triangle, say. So by the angle and by the size. So we're gonna talk about the angle first. So here, even though I have two acute angles, we have one obtuse angle. So here we start with obtuse. And then we look at the sides. Okay, so we have two sides that are the same, which makes it an isosceles. Try to color code it for you. We have triangle RST. RST. So this giant triangle here. Okay. And the reason it's important is because we got to look at the bigger picture, right? So these angles here. Okay. And if you notice, right? If you notice, the angles are all 60, 60, and you put those together, that's 60. And also the sides, 16, 8 and 8, 16, 8 and 8, 16. So here we have an equiangular, oops, it's hard to spell, equilateral triangle. The next one, triangle SRQ. Where's SRQ? Okay. Again, start by looking at the angles. Because we have this right angle here, we have a right. And then looking at the sides, no sides are the same. So we have scaling. Moving on. Triangle PRT, and it's getting kind of messy. All right, so PRT, looking at the sides, this side is going to be the same as this side because this is 16 and that's 16, which tells me that since this is 30, this is 30, right? Which means that this is 120. And so since it's 120, that's an obtuse angle. Because we have two sides that are the same, it is an isosceles. Okay. Moving on. I don't know how well we're going to see blue, but we'll try it. So for triangle TQU, so this little triangle here, sorry, we kind of already identified that one. It was an equiangular equilateral. And then finally the last one, I know, PQT. So PQT, okay. Notice we have that right angle there, so it is a right. And then looking at the size, 16/8, that means none of them are the same, so it is a scaling. Awesome. All right, let's keep going. So here's one of the challenge problems, and it's saying, can you classify these two triangles, right? So this is a triangle, and this is a triangle. Can you classify them by the size? So if we're classifying by the size, there's three options. It's either isosceles, scalene, or equilateral, right? And so one thing we have to do is I would just draw a triangle and label it JKL. Because it doesn't really matter where the vertices are. There's only three. You can't really cross them up. But they do create a triangle, right? And so what we have to do is we have to check, are any of these distances the same, right? Because on a coordinate plane, that's the only way we can check it, right? So all we're trying to do is find the distance between each one of these vertices. So I'm going to do this just so we can see it better, JKL. So the first thing I'm going to do is find the distance between J and K. Between 2 points is just the distance formula, or change in x squared plus change in y squared, right? So for finding the difference. So from J to K, so how did it get from -7 to -9? That was a difference, right? So I had to subtract 2. How did I get from negative 7 to positive 1? We had to add something. From negative 7 to 0, that's 7. From 0 to 1, that's 1. So altogether, we added 8. And we simplify a little bit. But I'm not going to go ahead and finish it. So here we got 4 plus 64, which is the square root of 68. So I'm going to leave it like that. Because if I do, well, whether I do or don't, all I'm seeing is, do I have any sides that are the same, right? And so the next one I want to check is K to L. And again, all I'm doing is finding the difference, right? Finding the distance. So how did I get from negative 9 to negative 1? I added 8. How did I get from 1 to negative 1? I subtracted 2. Okay. Notice it's the same numbers. So we got 64, 4, or the square root of 68. So we already know that it's an isosceles triangle, but we're trying to find out, is it an equilateral triangle? We already know that it's not a scalene because we have two sides that are the same. Now we're trying to find, is that third side the same as the other two? So we're going to check the distance from J to L. And once again, that's just my change in X and my change in Y. So how did I get from negative 7 to negative 1? I added 6. And for my change in Y, how did I get from negative 7 to negative 1? I added 6. So already I can see that they're not going to be the same. So that's 36, 36, 72, right? So here, 72. So in this case, I can classify triangle JKL is isosceles. Okay. So you go ahead and try to classify this one, right? Is it isosceles, scalene, or equilateral? So go ahead and pause the video, put your answer in the chat, tell me what you think. So in the chat, you're either going to tell me isosceles, right? Or you're going to tell me scalene or equilateral. So go ahead, pause the video, and then resume to find the answer. All right, so I hope you actually paused the video. And so I'm going to do the same thing. JKL, the only reason I'm writing or drawing this triangle is so that I can get a better visual of what I need to check, right? So I'm checking from J to K. So from negative 3 to positive 2, I added 5. From 2 to 6, I added 4. Do a little simplifying, that's 25, 16. And that gives me the square root of 41. So this is 41. Okay, so then the next one I check, I want to see KL. So from K to L, so from positive 2 to positive 8, I added 6. From 6 to negative 1, I subtracted 7. Do a little simplifying, 36 and 49. And we get 85. And so then the last one I want to check is from J to L. And so from negative 3 all the way down to 8, I added 11. So from negative 3 to 0, that's 3. From 0 to 8, that's 8 more. So altogether is 11. For my change in Y, so I'm going from 2 to negative 1, I subtracted 3. So 11 is 121. 3 squared is 9, gives me this root of 130. So since no sides are the same, then I can classify triangle JKL is scalene. All right, moving on. So now we're getting into some algebra with these triangles. And so reading the problem is step one and probably the most crucial because it gives you information that you're going to need. So for this one, it says if triangle MNP is equilateral, pause. Equilateral means that all sides are the same, right? They're all congruent. And it says find x and the measure of each side. Well, the measure of each side is the measure of one side because they're all the same, right? So the first thing we got to do is set up an equation that's going to help us solve for x, right? Now, the key thing here is that we know all the sides are the same. So choose, right? Choose which two you want to set equal to each other. It does not matter which ones because here we have an equilateral triangle. So I'm just going to go with this one and that one, right? So we set up my equation 4x minus 25 equals x plus 14, solve for x, right? So I'm going to do two things at once, subtract x and add 25. So on the left side, I got 3x. On the right side, I have 39. Divide by 3, and we get x to be 13. Now that I know that x is 13, the only thing that's left to do is substitute it into either x, right? And I should get exactly the same thing for all of them. So here I'm only going to check one. So I can say NP, right? Side NP is equal to x, which is 13, plus 14, which is 27. Right? And so here I can say NP is the same as MP, and that's the same as MN, and they're all equal to 27. Cool. Okay, so here's the next problem. Again, reading the problem is the most important part. It says triangle DEF is an isosceles triangle. Pause. I forgot to do this earlier, but an isosceles triangle has some key characteristics. An isosceles triangle has two sides that are the same or congruent, and it also has two angles that are congruent. And these angles is what we call your base angles. Here is what we call the vertex, or kind of where the triangle starts. And so one thing to remember is the angles that are opposite of the congruent sides are the congruent angles. Okay. So back to the problem. All right. So it says triangle is an isosceles triangle, and they're telling you exactly which two sides are congruent. It says side DE is congruent to EF. So remember, by definition of congruence, if two things are congruent, then they're also equal, right? Or they're the same. So these two are congruent, which is going to help me find x. Once I know what x is, to find each side, I simply substitute in for x, right? So that's our first job. So I get my equation from knowing the fact that they are congruent. So we're going to set those equal to each other, solve for x. So doing two things at once, subtracting x, adding 13. On the left side, I have 3x. On the right side, I have 30. Divide by 3, we get x to be 10. Once I know what x is, simply substitute it in, and we get our measurements, right? So here, EF, plug 10, 5 times 10 plus 17. Simplify, 5 times 10 is 50. 50 plus 17 gives me a measurement of 67, right? And essentially, D&E or ED should be the same, but to play it safe, let's go ahead and try it. So 8 times 10 is 80. 80 minus 13 is indeed 67. And so this last one, DF, should be different because there's only two congruent sides in an isosceles triangle, right? And so here we have x plus 21, where x we found to be 10. So 10 plus 21 gives me a measurement of 31. Okay. So here we have an exterior, what we call the exterior angle theorem, okay? And so this is a little important because it's supposed to meant to save us a little bit of time. So it starts on the fact that if you know these two angles, right? It doesn't say they have to be the same. If you know those two angles, when you add them up, they're equal to this, third angle that's directly outside, all right, their exterior angle theorem. And so here's why it works, okay? It works off the fact that if you were to add all three angles inside the triangle, they add up to 180, right? So let's do this. So for our purpose in our demonstration, let's say angle 2 measures 60 and measure 3 goes with, let's make it easy, 40, okay? And we're trying to find this third angle, correct? So we start with the fact that we know that if we were to add, we'll call this x. If we were to add both of these two angles together, or all three of them, sorry, they should add up to 180 degrees, right? So 60 plus 40 is 100. Subtract, and we get x to be 80. Okay, cool. Now, one thing I want to mention, we added these two, and it was equal to 100, right? So let's keep going. So now if I want to figure out what is the angle, or what is the measure of angle 1, right? So one thing we got to remember is these two together is a linear pair, right? They're supplementary. That means that they add up to 180 degrees, okay? So working these problems out, I know they're supposed to equal to 180, correct? We'll call this one y. 80 plus whatever y is supposed to equal to 180 because they're a linear pair, right? They add up to 180. So solving for y, we subtract 80 and we get y to be 100. Okay. Now notice that, well, you can't really see that. Notice that y, right? Y was equal to 100, where these two angles was also equal to 100. And so if we kind of put that into perspective, what we just talked about, what we just said, sorry, is the fact that if we have y, which in this case is angle 1, is equal to whatever the measurement of angle 2 plus the measurement of angle 3 is, right? So that's why it works, and that is what we call the exterior angle theorem, okay? It's helpful, yes, to remember it. Do we need it? Not really, but it's kind of like a shortcut, or sometimes if you're stuck, it does help us, okay? So let's look at some examples. So looking at example 1, so we have couple of triangles in here. We got two. So we got this triangle inside the bigger triangle, right? And so we start off with this one. So knowing the fact that these three angles, when you add them up, should equal to 180, right? So if we do 180 minus, by the way, that means 90 degrees, right? So 180 minus 90, we're at 90, okay. 90 minus 43 tells me, minus 43, tells me that angle 1 tells me that angle 1 is equal to 47 degrees, right? So here, 47 degrees. And so now we can go venture out, right? So these two together, so we got 47 plus 12, gives me an angle measurement of 59. And so that's important because I'm going to highlight, because this bigger triangle here, right? This bigger triangle has this 90-degree angle and now has this 59-degree angle. And so again, no matter what the triangle looks like, you're always going to add up all the angles to equal to 180. So here, 180 minus 90 gives me 90. And then 90 minus 59 gives me 31 for angle 3. And so now there's two ways we can go and find angle 2. One, we can do this linear pair here, right? So the linear pair would be 180 minus 42, or we can also do these three angles here, and we know that they're equal to 180, right? Doesn't matter which one you do. Either way, we should get the same exact answer. Whatever you choose to do, we get 137 degrees, right? And so real quick to check that. Awesome. All right, so moving on. So looking at the second one, second problem, it's important that we read this. That's telling you that we have these two lines that are parallel. And that's important to us because that tells us that we're going to have angle pairs that are going to be congruent, right? And so it might be a little hard to see here or now, but this angle and this angle are alternate interior angles. And because the line L and line M are parallel, that means that they're going to be congruent. So if they're congruent, that means angle 3 is 73 degrees. Okay. And angle, let me change the colors. Angle 3 and this angle 73, they are supplementary. They are a linear pair. So since they're a linear pair, they're supposed to add up to 180. So 180 minus 73 gives me an angle measurement of 107. Okay, and now this angle here and this those two angles put together, they are also alternate interior angles, which means that they are going to be congruent. And so if this entire angle is supposed to be 107, to find angle 2, we do 107 minus 49, which gives us 58 degrees. Could you have found it another way? Yes. These three together are supplementary, which means they add up to 180. So we could have done 180 minus 73 minus 49, and that would have also given us 58. Okay. So now the next angle we can find is angle 4. And the reason we can find angle 4 is one of two things. One, we know that these three should add up to 180, right? So we can do 180 minus 58 minus 73, and that gives us 49. The second reason we could have figured it out by just looking at it is the fact that here and here, those two angles are also alternate interior angles. So then we can find this last angle 5, and that one angle, 49, are supplementary or linear pair, which means they add up to 180. So subtract, and we get 131. All right, moving on. So here's a perfect example of what the heck do we do, right? So this is where we apply our exterior angle theorem. So notice how here this angle is not the one we need yet, right? So to start off with, we're going to say angle 4x minus 7 plus this angle up here, which is 86, is supposed to equal this exterior angle out here, which is 9x plus 4. Solve for x, right? So combine like terms. So we got 4x plus 79 equals 9x plus 4. And I'm going to do two things at once. Subtract 4x from both sides and subtract 4. So we got 75 equals 5x. Divide by 5, and we get x to be 15. Okay, so once we know that x is 15, I can go in and substitute it either one, right? So if I plug it in here, 4 times 15 is 60. 60 minus 7 is 53. So this angle will be 53 degrees, right? Or I could have also plugged it in here. And let me back up. So the reason I played it in there, because these three angles should add up to 180, right? So add them together, set it equal to 180, solve for y, right? I could have also done, plug it in here. So 9 times 15 is 135, plus 4 is 139. So 139 degrees. And again, so those two together added should equal 180, right? So if we were to do that, then we can solve for y. So either way, 7y minus 1 plus 139 should equal 180. Subtract 139 from 180 and we get 7y minus 1 equals 41. Add 1, divide by 7, and we get y to be 6. All right, last problem. So it says in triangle RST, okay? So I'm just going to draw my beautiful triangle RST. It says if angle R, okay, so angle R is 5 more than twice x. So 2 times x plus 5, okay? And it says angle S, okay, so angle S is 1 more than x, so x plus 1, and angle T is 16 less than 7 times x. So 7 times x less means subtract 16. And so we're trying to find x and the measure of each angle. Okay, so one thing we got to remember again is that no matter what the triangle looks like, when you add up all the angles, they should equal to 180. So that's exactly what we're going to do. So 2x plus 5 equals, so 2x plus 5 plus x plus 1 plus 7x minus 16 equals 180. Okay, so bunch of good old algebra. So 2x plus x is 3x, plus 7x is 10x. Then we got 5 and a 1, which makes 6. Minus 16 makes minus 10. So add 10, and we get 190. Divide by 10, and we get x to be 19. So now that we know that x is 19, our brain should be telling us, hey, go back and substitute it in to get the measurement of each one, right? And so that's exactly what we're going to do. So when we go back and substitute it in, the measurement of angle R is, so we do 2 times 19, which is 38, plus another 5 gives us 43 degrees. The measurement of angle S is 19 plus 1, which is 20. And the measurement of angle T is 7 times 19, which is 133, minus 16 gives us 117. And one quick way that we can check whether we got this answer right or not is if we add these three angles together, they should add up to 180, which they do. Okay, your homework is on Schoology. Get started.